Hey guys, next lesson you are going to create an analogy of electricity, and as we do not have that much time I want you to prepare and to know what you're going to do so you can do it in class and present your analogy to your classmates and during class only in 40 minutes. So the explanation what an analogy of electricity is I'm going to do right now. First of all, let's take a look at electricity. This is something you have done last year with Mr. Sebring. And with Mr. Sebring, we saw a circuit, electrical circuit, we have a battery, and something is going around in circles, and that thing that is going around in circles, that takes electricity from the battery, gives it to the light bulb, and then the light bulb uses that energy to convert into light and some heat. And it goes back, gets new, and so on and so on. So something goes around in circles, and that something that goes around in circles takes something from the battery and goes it to the light bulb. And if you make an analogy, you have something that is a different story but works the same. For instance, my analogy, well, Mrs. Sebring uses leprechauns all the time for this, but my analogy is with pizzas. We have a pizzeria over here, and we have these delivery guys on mopeds going around in circles to homes and then back to the pizzeria to get new pizzas, and so on and so on. And what do they? So, what is going around the circles is the delivery guys, on the mopeds, or e-bikes these days. Sometimes they are e-bikes, and what they bring, what they get over here are pizzas, and they bring it over, they give it over there. And if we think about electricity, we're constantly thinking about the potential difference and the current. And the current was how fast these electrons go around. If we go back over here, how fast the arrow moves. And basically you measure that the amount of arrows per second. And if we go back over here, so the current is how fast the things that go around in circles move, but that's not the exact definition. The definition we're going to use for current, the amount of delivery guys passing each second. That is what current is in my analogy, and you need to think of something else, so you have a different one, but it works the same. And a voltage or potential difference, voltage or potential difference, and potential difference is also PD, and that was, well, how much they give or how much they give away get. So that is the difference, and they get pizzas at the pizzeria, they give pizzas at the homes, so that is the difference in pizzas for each delivery guy. Okay, and it is not how much much pizza they have, but it could be the case that for some weird reason he has one pizza. When he goes back to the pizzeria and he gets two more, then the difference is two. So you have two pizzas as voltage over here, and then it gives two pizzas back. Over it gives two pizzas, and then it's two again. Okay, guys, what do you need to do? You need to think of in teams during class an analogy like I did. You need to draw it on a big whiteboard, and I'm going to provide the whiteboard, and I'm going to provide the whiteboard markers and wipers, so no worries about that. And the analogy that you have drawn, you need to write down what current and what voltage or potential difference is in your analogy, the knowledge of your group, and then you, yeah, in the end, you need to present it to the rest of your class, what your analogy is and what your voltage and potential difference is. Okay, so you need to think about an analogy you could use in your group and yeah, that's basically it. Um, what you need to do. So homework for this lesson is to think up an analogy, so a story of something that goes around. There has to be something or someone that goes around in circles, and that something or someone needs to get something from one place and give it somewhere else. Okay, that's it. See you in class. Bye.